Hi everyone, welcome to this tutorial. I'm going to go through PySpark DataFrame and let's see how we are able to work with structured data. And basically the challenge on this tutorial is the volume. And also we can also consider veracity, where we have missing values, null values. And we want to start from zero, right, to see what we can do, how we can start, and how we can uh, make all customizations going through. All right, perfect. So for starting point, we need to go through this data. All right, so the data is on my Google Drive. You just need to click on this link and download this data, right? I do click on this. Since this is huge data, about 600 megabytes, so it's very obvious we cannot see data. You can download it, right? Once you download data, please uh, copy and paste it on your Google Drive. All right. So like me, that data is on my Google Drive. So download data about 600, let's say 50 megabyte that we are considering as huge data. So even, even if you download this data, you are not able to open this CSV file. All right, this is a structured file. And data frame, right? So data frame is similar to databases, means uh, a data having rows and columns. That usually these columns, we call them named column or schema, or the label columns, that we can specifically go through a specific column and do whatever we need, analysis, aggregation, and any type of statistics or analysis or any processing you wish to go through. It's going to be feasible. So let's just start and see what we still needed. So uh, we can initialize, PySpark. So to initialize PySpark, we need to, type pip3 install PySpark. All right, and uh, you can run it. And in this case, it's going to install PySpark. Let me zoom in. All right, it's going to install PySpark, the latest release. So this, syntax is valid while you are on the same session. I mean, the current session that we are working on, this Jupyter notebook. Once you close this session by, pressing, this close button, open, and if you open new tab or a new window, right, you need to again install it, right? Because it's going to be on demand once your session is active. Once you close the session, you need to again, install PySpark. So, all right, as you can see here, PySpark was installed successfully, and it's going to be the latest release. And now we need to work with Spark session to be able to work around with data frame. So data frame is a database, or let's say is a data structure in Spark that we are able to work with structured data, like the tables having rows and columns. So Spark session, we can call it a entry point, right? Or we can call it a driver point, or we can call an interface in Spark that we are able to create data frame, register it as table, execute SQL queries, caching mechanism, and many more that we can do so. So before going through this Spark session and declare Spark session, we need to double check two things: CPU and memory, right? We need to make sure that high amounts of memory and CPU are available. All right, to check the available, let's say, memory. So in this case, you can easily say free space dash h, right? And then if you run it, it's going to say that on this machine, which is, the cloud-based machine running on Google servers, I do have 6.4 gig free of memory. That's perfect, right? For this tutorial is well enough. Let's do check. Uh, let's say to check the available cores. All right. So in this case, you can type nproc. All right. And if I run, it says there are only 2 cores available, right? So because we are working with the free version of this Google Colab, and we have 2 cores, it means that if you have 2 cores at the same time in parallel, 2 tasks can be executed, right? Because we have 2 cores. Each core is going to get advantage of, parallel processing a concept and take over one partition or a part of data frame for processing. Let's go through it. All right, let's go through it. So a few things here we have to do. Linking with the Spark. So we need to import PySpark. Then we need to import that Spark session I mentioned, that you can call it interface entry point driver. This is Spark session is going to handle data frame. So then we need to create an instant. We name it Spark. This is going to be a data frame instant, and Spark session builder. So you can give a name. All right. So this backslash I used to be able to break down this line. So you can use it like this. You can put it all this stuff together back to back. So, and then that it's going to be very long. That's the reason I'm using these backslash to say, all right, please break it down into separate line. So application name. So .master, you have to mention that how many cores you want to use. If I say local means the same machine. The same machine means the machine that we are using on this cloud, means this Google Colab. So, and then inside this bracket, this script bracket, you have to mention the number of cores. So we have 2 cores, right? We have 2 cores. It means that if I say 1 means, okay, there are 2 cores, but I just need 1 core. But for parallel processing, it's much better to have at least 2 cores. All right. So you can mention 2, or if you press 3 or 4 or 10 or 100. So, I mean, you don't get any system error, right? If even you put 100, it's going to restrict you to 2 cores because there are only 2 availability. All right. So we use asterisk. Asterisk means use as many as available cores on this machine. All right. Then we know that is 2, right? But if you're not sure how many there are, take it easy and use this asterisk. Then we need 2 configurations for memory and cores. So we need to do configuration for the, executor and the driver. So Spark executor memory and Spark driver memory. So guys, since we are working on single machine, executor and driver, they are all settling down on this single machine. All right. So for us, executor is very important because the main processing, the parallel processing is going to be happen over this executor, means this machine. Driver is going to be like, as like a leader, right? It's going to look after the jobs, look after the, if the processing is going healthy, to check, the resources, the bandwidth, everything is going to happen, and it's going to come over from operating system and let's call it cluster management, and driver is going to be like the leader, right? So for this driver, we are not going to take too much memory unless you want to do lots of overhead. You want to add lots of overhead over the driver node, or in this case, let's say a driver application on this case. So what I'm doing here, I would say that since we have 6 GB free of memory, I would say that, okay, let's just spend 4 GB for executor and 2 GB for driver. So you might ask me, why not to increase them like 4 and 4 or 4 and 10, right? So guys, we need to be very careful that if you assign more memory to the Spark driver and Spark executor, then the system capacity. All right, we have 6 GB, but you want to specify 100 GB or 10 GB, right? More than the capacity. It can lead to memory contention and performance issues. So when memory is over allocated, let's call it over allocation, it can cause the system to swap memory to disk, right? Because there is no well enough space in memory, and Spark needs to move data from memory on the disk whenever the processing is done, and then it's going to take data one by one, partition by partition from disk. So moving data memory to disk, disk to memory, is going to be the problem of increased input output overhead, right? Because you need to read data from hard disk and you need to send data over to memory and vice versa, right? It's going to increase the I/O overhead and reduce performance at the end. So also sometimes on some use cases, that if you have really huge data, like terabyte of data, but you want to do it on the gigabyte of memory, you will face with out of memory errors, right? And potential crashes will come up, for Spark applications. So we need to be very careful about this configuration. And this Spark executor core, I would say that, all right, for execution, I need 2 cores. And I'm not mentioning driver core. If you don't mention, it's going to take just 1 core, right? This is the default one. So, and of course, I'm going to take advantage of this compression. I would say that if data is huge, please apply this compression also on the data, because compression helps to reduce the size of data. Why not to apply it from now on? Let's now run it, okay? To initialize Spark. And basically a Spark session for DataFrame. Perfect. So you can see that version 3 local asterisk means as many as core available and the application name. Perfect. So then we need to connect to Google Drive. For what reason? Because guys, we need data, right? On the left hand side, if you see this one, right, it says files. If I open these files, so you can see that here is sample data, and of course here you can see this one. There is says mount drive. This is Google Drive. Here you can run this one, and it's going to connect us to Google Drive. So it's going to ask which ID you're going to take over, and you need to log in with one of your Google accounts and continue. So then it's going to take over my Google Drive here at the left hand side here. All right, it's still working. All right, it says mounted. So just press this refresh button and Drive is here now. All right. So at the beginning, as I asked you guys, please download this data, right? Please download this data and place it on your Google Drive. All right. So what I did, I mean on my Google Drive, my drive. So I did it here on this one, files. All right, my data is here on this folder. I created this folder, files, and then inside the files, I provided, and I upload this data here, right? Data.csv. So how I'm able to get connected to this data, because data is now here. How we can do that? You can click on this 3 dot and it says copy path. You can say copy path and done. We don't need that. All right, we don't need it. So here we need to read data. So I wish to name it DF. All right, means data frame, and then a Spark, which is this initialization here, right? This is our Spark connection. So Spark dot, if you press dot, of course there will be the wizard, and we need to go through read, and then you have to mention format. All right, and then in the format you can mention what type of data you want to read: JSON file, Parquet file, CSV file, Excel file, right? There are many more that these are all structure. So I wish to say that this is the CSV file. All right, so then load here, single quote or double quotes. I mean, never mind, you can use either. So Control V, because we I mean, here, if you remember what I did on my drive on, files here, copy path, right? And then you can directly take it over here. Content drive, my drive until here means Google Drive, right? And then files and data, it's gonna be your file. So since this is, structured data, why not to say infer schema? Infer control space, right? Infer schema. I cannot see it, but we can do it by, I mean, let's do it like this. Schema, right? True means also take a schema for me, all right? And header true because we want to collect the first row of these data as the header, all right? So then here, what I want to do, we could read data and let's say show this table, all right? df.show, and sometimes we need to use truncate, right? Truncate means please write the complete value on each column, all right? So if you don't mention truncate, right, to be able to position and place all data in one screen is going to just take, a part of your, the entire message or entire value. So, but if I say truncate, true, I would say that, okay, please print out every single character and digit from data. Show a schema. Why not to show a schema? Because here we said, and bring schema for us, right? df.print. If you press tab, control space. All right, it's not there. Don't worry, you can type it. Print the schema. And why not to some information? So for some information, I will say that print please df.count to see how many records we do have here, and the length of this df. Maybe to say columns. All right, we don't need to load the entire data because it's 600 megabyte. I would say that just columns and length of the columns. All right, it helps to avoid loading entire data and then getting the length. So let's run it. Shift enter. You can press shift enter and we can go through this data. So you can see this cursor. Cursor is here, means still, still it's reading data, right? Reading data, because here Spark DataFrame should decide that how many partition to create. So guys, there is a mistake. I need to stop it, right? I need to stop it because this one I need to remove it, all right? Because truncate is not a library or is not the package. Truncate is attribute here, right? Truncate, okay? And then I want to run again. So still cursor is there, right? It's going to read data. So bear in mind that we have only 2 cores, right? And it's going to read data and then show table, print schema, and few more information for us. All right, you can see that data is here now. What we can see here, since this is huge data, is only showing top 20 rows. Okay, that's enough for us to get, to get the basic idea of these data. So ID, age, salary, score. So you can see that age, we are having null values, right? And for score, of course, we have null values. Sales, height, weight, gender, category, income, expenses. So this is the data. We might have null values, for other columns. We are not sure. We have to check. All right. before any processing, guys, let's say before doing any statistical analysis, before doing any machine learning or optimization or whatever you want to do, we need to get familiar with data, pre-processed data, and because data is huge, right? We are not able to open it directly on the Excel file, and filter out data, and then go through those records that you want to, you want to drop them. You can easily drop them, but here we don't have that option because data is huge. We need to import it somewhere here like Spark and read data directly and get idea about that. So this is about, this root means these are these are or schema or the column label. So if you see here, we have about 10 million record. Is huge data, right? That's the reason it's 600, about 600 megabyte, and 11 columns. All right, because here I said the length of columns, to count how many columns there are. Perfect. We need to know how many partitions there are, right? Because this is parallel processing concept behind that. And if you want to check how many partitions there are, df.rdd.get number of partition. All right, and then you can run it. So it says there are 6 partitions, guys. Spark, specifically for data frame data structure, is going to partition your data automatically. So here is 6, right? So how many, let me take this calculation. The size of data was 641 divided by 6. It means each partition is going to take 106 megabytes. So, the default size for each partition is 128 megabyte. So it's, let's say this is the healthy number, 128 megabyte, because if we have many partitions, 128 megabyte is going to be really easy. And of course, easy means from processing point of view for CPU and memory would be feasible to process, 128 megabyte. Sometimes based on, the hardware, you can take 512 megabyte as well. But it's much better to don't go beyond 512 megabytes. All right. Or maybe it's better to take over 128 megabyte. So guys, but this 6 is not a guarantee. You might take different number. If you run exactly the same thing, you might get not 6. Maybe you want to get 4. Maybe you want to get 6 again, or maybe you want to get 7, or maybe you want to get 2, right? So because Spark, as I mentioned, Spark engine automatically handles the partition. So this default number of partition might not evenly distribute data across the cluster, right? It's going to be leading to inefficient computation. This is the problem at this stage we have. So it's always, or let's say it's often necessary to repartition data frame after reading the data, right? In order to achieve a more balanced distribution of data. So, but we need to consider a few things together to make sure basically what we need to consider. So there are a few things I wish to add it like as a text here. All right. The first thing that we need to consider, let me close it, is going to be data source input split. All right, split. So, or maybe I can take it like dash, like this one, or maybe as, let me do it like this. Maybe let's say partitioning criteria. All right, the first one is data source input split. All right, so PySpark, guys, communicate with many data sources. Let's say HDFS from Hadoop file system, a cloud storage like Amazon S3, or a database or CSV, or can read a different type of data. But the data source, some of these data sources have their own way of splitting data into the chunks. Let's say like this HDFS. you might have data ready into, let's say, 10 partitions beforehand. And whenever you read that data, so it's gonna to Spark gonna to take over exactly that 10 partitions and and process it. Or even for Amazon S3, or for some other data like CSV, like text file, that data is still structured, right? But we have no any specific chunks or let's say partition beforehand. It's going to consider some other option. So let's say here default partition size. All right. So this default partition size, this is exactly that 128 megabyte that I mentioned. All right. So let's say that PySpark has different default size for partitions, right? Once we read data, if we read file, like CSV file, JSON file, Parquet file, and basically in this case, I'm going to consider, a text file, CSV file, and let's say JSON file, and why not Parquet file? All right. So once we read this type of data, there is there is a configuration that is going to say that 128 megabyte is the default size. That's the reason, guys, we are having something like this here, right? 6 partition. So you can change it. How we can change it is going to be easy. We have to say max partition, uh, bytes. All right, or maybe it's going to say that Spark dot SQL, right? SQL dot files dot, this one. Yeah, the first one. So let me say max partition. All right, is here, right? So what does it do? You can see that, guys, default is 128 megabytes. The maximum number of bytes to pack into a single partition when reading the file. So what type of file? Basically a text-based file, JSON, CSV, Parquet, ORC. And that's the reason. If you want to change it, right, you can really take it easy, and then you can copy this one from here. All right, you can come back here, and if you want to change it, you can easily do it here. Say spark.configuration.set. What to set this attribute, set it to. So here you have to mention it like into the bytes format. All right. So for instance, here, if I say, 128 multiplied by 124, it's going to be the kilobyte, and again multiplied by another, exactly gonna be this one, right? So first 1024 is for converting to kilobyte, because this is megabyte. And then how to convert from kilobyte to byte, again another 1024. All right. And then you can define the default value here, that what you need, but let's keep it as the default one. So another stuff that we need to consider, Spark consider, is going to be resource, let's say, allocation. So guys, once Spark reads the data, consider partition size, default partition size, and then resource allocation. Resource allocation means that the availability of cores and CPU. Sorry, core and memory, right? The availability of core and memory. Also, these are really important. That's the reason I would say that if you get this exercise and if you run it on your own machine, even on this Google Colab, you might get not 6, maybe 5, maybe 7, might be 2, because default partition size is one factor that we want to consider, and resource allocation, how the CPU that you wanted to take over, how they are busy, like how memory are free, right, that they want to be considered. So another thing, guys, we as a end user, we have to consider is data locality. Data locality means that it's really great idea to get data, right, let's say on the same node or on the same network, because it's going to reduce or minimize network traffic and improve performance, because we have to read the huge size of data. All right, so it's better to be on the same network or on the same machine to minimize network traffic. So this is, our responsibility as an end user. So once we get, so I mean, here I've talked about file base, oh, sorry, here, yeah, it's here, right? File base, partitioning. At very advanced configuration, we are having something we call non-file, let's say non-file based data. All right, so what does it mean? This one means like NoSQL. All right, NoSQL. Let's say Kafka. Let's say Amazon Kinesis. All right, let's say cloud services like Amazon, DynamoDB. Guys, these are new generation of data types. Or let's say Google, Bigtable. So what else? I do try to remember. Let's say object stores like Amazon, even S3, Amazon S3, or Google Cloud, right? Google Cloud. So what else, like Neo.js4? These are graph databases, right? Amazon, Neptune, or data warehouses like BigQuery from Google, right? So like, let's say like Amazon, Redshift. So, and many more, right? Snowflake, uh, and few more. So for this type of, data that we want to read it, Spark can do a few specific job, and also we as an end user that we want to be like a database or, big data engineer. What we have to do, PySpark ensures that data is efficiently distributed across the cluster for parallel processing, right? This is the main idea. So, and but in this case, for this type of data, what we have to do, the partitioning can depend on options provided during the read operation. It means that, guys, it's much better while reading this data that, as I said, that these are like advanced consideration. You can do it at your own, let's say spare time. If you want to read the typical data, it would be really recommended to add options, right, during the read operation, such as predicates. All right, I'm going to give you hints. Predicates or column-based partitioning. So these are really important. And last stuff I wish to discuss is about custom partitioning. All right, custom partitioning. So in Spark, as I mentioned, since Spark DataFrame and basically Spark Engine would, is going to partition your data frame automatically. Sometimes that, this number 6 is not efficient, right? You need to repartition data. All right. So how to repartition? We have to repartition. This is one method that you can increase the number of partition, or coalesce, you can decrease the partitions. It means that you can increase it to 8, right? You can decrease it to like 4. Yeah, you can increase it and decrease it. All right, with coalesce. So these are, the stuff we need to take into consideration while doing partitioning. So at this, and at this case, 6, it seems, really nice partitioning the number of partitions. But if you find 7, you know that we have 2 goals. It's better to get the coefficient of number 2, because we want to make CPU, right, to be run in parallel. without wasting these resources. Because if you have 7 and then at one of these, runs that you want to get advantage of, CPU for parallel processing, 2 partitions gonna to be done, another 2 partition gonna be done, and then 2 more partition will be done, and 1 partition is still there because we have 7 partitions, right? And then because of that 1 extra partition, we have 2 cores. 1 core should be idle without doing anything, right? And then needs to wait for another core to complete processing over that extra partition, partition number 7. It's not recommended. It's better to do not waste core without doing anything. We can spend it for other application and requests. So, all right. So here we have, let me go through, this. All right, let me go through, this calculator, and then we have 641. If I divide it by 4, even, because I'm going to decide to decrease the number of partitions. Even increasing partition is not a great idea because the parallel processing takes time. All right, you want to keep it engaged. So what we can do, there are different discussions that we can increase the number of partition or decrease the number of partition. So let's say that, let's do some exercises. Let's say that I want to create new data frame 2, and I want to say that df dot repartition. All right, how many partition? I wish to do it in 8 partition. So then you can also check it to make sure it's the right RDD dot get number of partition. So let me, if you run these, so we expect to get now 8 partitions, right? And since it's running, let me do one more thing. Guys, if you want, you can also decrease it, right? How to decrease? Maybe here, since it's working, to get number of partition, I want to say that df maybe _2, df dot coalesce, right? So it's busy, right? Because the compiler is busy here. I will say that coalesce. All right, 4 partition. And then you can, take the same approach and calculate it. All right, so you can also decrease. So let's move forward. Let's say that I wish to say another data frame. All right, I wish to say that, okay, df repartition. Let's do it wisely. So repartition. So because here at this repartitioning, you can see that now is 8 partition. It's blindly going to repartition. It's going to shuffle data, all right, to create 8 partitions blindly. So let's ignore this blindly and let's make it wisely. So here I want to say that repartitioning, df dot repartitioning, repartition. So please repartition based on, let me see that, the column, this one. Let's say category, which is categorical. You can see that A and B, or gender. So the rest is going to be very risky, right, to take them as the categories, because if you take them, there would be many partitions. I want to say that based on category. So if I say here, go through repartitioning over these category column. So what do we expect? We expect to get 2 partitions. All right, let's see that. df3 and run it. Or maybe you want to say that I wanted to copy same thing. All right, so 2 partitions is going to be each partition 300 megabyte, about 300. Maybe you want to say that it's not healthy number for me. I want to say that please repartition by this category column into 6 partition, not 2 partition, or maybe 4 partition. All right, you can increase them. It's going to be 2. If you take 4, it's going to be 2 partitions specifically for category A and other 2 partitions for category B. All right, so you can make it 4, for instance, 4 partition, or maybe you can take 6 partition. All right, so you can run also this one. And one more thing that here we can do so is about okay, what I'm thinking, let me stop this one and change 4 to 6. All right, and let me run it by 6 partition. All right, so one more thing here is we have one more, let me name it df5. We have one more method. We call it df dot repartition by range. Very important, very nice method, repartition. Sorry guys, repartition by range. So what does it do? This function, guys, is used to evenly distribute data across partition based on the range of keys. What is this key? Let's say income column. All right, so if we go over here, income, you can see that these are number. So guys, if you want to repartition your data, that the partition, it's not going to be based on the categorical column, because if it's not categorical, it's going to generate might be millions of partitions. But if you wish to still, if you wish to still repartition your data based on non-categorical column, it's better to use repartition by range and go over the column you wish. Let's say income. I would say that repartition this data based on income column. All right, but do it into 10 partition for me. All right, so it means that create 10 partitions, and this function is going to evenly distribute the data across partition based on this range, right? By using this, you can ensure that data with similar keys are stored in the same partition, guys. So it means that if income is like 10, let's say if it's going to be like 8K, 70K, right? 66K. You can make it sure that this 70 is going to be all income by 70. They're gonna be in the same partition. All right. So, but if we have many 70, maybe it's going to move to another partition, right? But it's going to guarantee to ignore skewness, right? Means that it's going to put data evenly into the same partition. Why is it important? Because it's going to improve efficiency of some certain operations like joins and aggregation. All right, join and aggregation. I will go through another video and I will discuss about this join and aggregation. So what else? Let's copy this one and make sure everything is working as we expect. Data frame 5 and run it. Okay, make sure to how many partitions there are. Perfect. So we can do so. Might be there would be a question for you that how we can get access to each partition, like partition 4, like partition 1, or partition 10. So guys, here it's not really or let's say it doesn't really make sense, to see the partitions individually, because for us processing is important, distribution is important, and I mean, it really doesn't matter that your data, like number 70s, they are in partition 1, or they are gonna be in partition 7, right? At the end, your processing is important. Because of that, the partition of data is an internal implementation, right, in a Spark engine, and there is no a direct method to access or print the content of a specific partition. We are still able to do so. We need to might be converted to RDD or data sets, data structure, or you need to do some, few more coding using Python to get access to specifically to each partition, but really not recommended. But for some reasons, all right, you can see the right 10 partition as we expected here. So, but let's say for some reason, we want to write data frame to disk. Why we need that? So we need it, guys. Let's say this is useful for optimizing data retrieval and query performance. So why it's really important? There is like very valid reason and like business cases for the reason, because sometimes we are having huge data like millions of record, trillions of record, or terabyte of data, but sometimes you wish to collect data only for like females, all right, or for just males. What we can do, we cannot do it with Excel, right? We just need a platform or a technology like Power Processing or Spark or Hadoop, right? To take data, process data, and take over only female, or take over only, let's say, category A, or take over only, a specific requirement on the data. All right, and then you can go ahead with the rest of processing. This is very, very, let's say, valid reason. And another reason would be you have two, let's say, two applications, or might be you have one internal application and one external application. The external application asks you, they need data from only category A, for instance. All right, you need to collect these category A like every hour or every 6 hours or every day, right? Or every week, and then transfer it into like as an transfer it to an API, or maybe like a JSON file or whatever you have it as an API. So then transfer it to that external application. So how we can do so? Something like this. Data is huge. Read data, and then write data into a disk, and then the external application can read data from your data. How we can do it? Let me take over first this data frame 5, and then I'm going to open these files. All right, so df5 dot write dot option. So the option means that header true means, I mean, if you want to write data into disk, please get the header, right? I need the header. So backslash means go to next line, press, tab, because I need to put them everything separately into different, lines. So I want to say that partition by, okay, this is the key. Please do it based on gender. All right, because I want to get female and male data separately. Backslash. And then mode, you have to mention if this data is already existing, you need to say overwrite it or append it, right? Overwrite, I'm going to use overwrite, and then I want to save it as CSV file. All right, CSV file. And then let's name it gender from data frame 5. All right. Then we can run it. Or maybe let me to open or insert, let me insert more code cell, and I want to run it. Okay, let me run it. And once you're running, the left-hand side, which is going to be our hard disk, or let's say, or data that we can store, we can see the result. Let's do the same thing. Let me copy the same thing and paste it here. Let me take it over data frame 4. Data frame 4, here we have 6 partitions, and here we have 10 partitions. So df4, let me header, gender, override, but let me name it df4. All right. Let's see the result. Can you see that here? The cursor is now going to write data into CSV file, and the name of CSV file is gender underscore df5. So as we expect, it takes time, right? It takes a while because it's going to partition again data and then write it into a disk here into a CSV file format. So this partitioning, guys, really important stage for parallel processing. We need to make sure that we are having the reliable and very healthy number of partitions. All right, so you just need to go over these, criteria and consider your partitioning and the rest of exercises with it. So you can see that, right? This gender underline df is coming up, right? Is going to coming up. So what we can do in the meantime, you can open it. So still writing. So we should wait. So maybe here also run this one. Okay, so okay, it's done, right? It's done. As you can see, there's a tick, green tick. So if I press this refresh button, so you can see that these gender 5, you can see that we have 2 folder, gender female, gender male. Why? Because we said partition by gender. That's the reason we have 2 folders, female and male. If I go through female, perfect. You can see this one. How many partition we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What about male? Again, 10 partitions. Why 10 partitions? Guys, because here we use repartition by range. It's going to keep the same number of partitions because this is a range. So if I go over these, can you see the size of the file, the end of the line? I mean, that tooltip, it says 25.96 megabyte. All right. And also it's going to be 35 megabyte, and this one's going to be 29 megabyte, and so on. So guys, now we have the partition. If you double click on this, the right hand side, it says file is too large. So download it. So you can see that, guys, this DF4 is still going on, right? It's going to go over data frame 4. Do a same thing, right? Do a same thing. But we want to see, okay, also it's done, right? Let's see that. Let's firstly wait for this downloading. Or maybe I can. So data is here, right? If I click on these, guys, is coming up, right? Can see that the column gender is gone, right? It's not there because we partition it based on gender, and these are all based on female, right? These are the female one. And how many record there are? 450K record, right? At this file, it's gonna be so because we had, if you remember, we had 11 million record. It's gonna be like 450K, right? So also for the rest, you can see them, separately. So, or you can download them. All right, so let's go over this gender data 4. Still same as we expect, but if I open these, guys, 1 and 2, first one 146 megabytes, second 146 megabyte. It's going to be somehow similar for me, 146 megabyte, and this one also 146 megabyte. So guys, why this one generated 2 partitions, but here we had 6 partition? So guys, for repartition by range, if you use data frame right, it's going to keep exactly 10 partition. But for the other type of repartitioning, okay, means this repartition is going to decide, Spark will decide automatically that how many partitions and how many files or partition create. So you can see that it's trying to keep similar to 128 megabytes, right, into 2 partitions. And you can change it, right? You can change both of them. Means here I can copy this one and bring it here. I want to say that no, I'm not going to take 10 partitions because 10 partition is a lot. So I want to say that before doing so, repartition to 3 for me. All right, or you can say coalesce, repartition 3 for me. All right, and then write it. All right, and then write it. Let's say here, I want to say that I use repartition. Let me run it. So also for this one, I'm going to copy this one and paste it here. All right. So, but for data frame 4, we have 4 partition. This is the healthy number because 2 partition, I mean, was reasonable. Might be at this case, it's better to But if you want to get control of the size, you need to add something here. You have to say one of these option. All right. So here we have to add another option. Okay. We have to add another option. What we have to do, or maybe it's better to, but if you want to do it, if you just want to do it over this data frame, all right, you have to say, you know, dot option. Then you say maximum records, I guess it was per file. If I'm not wrong, it's like this. So I would say that, okay, 1 million records. If it's more than 1 million, create new file for me. All right, create a new file for me. So, or you can do it generally for every writing. How? Spark.configuration.set. Exactly the same thing, spark.sql.files. If I'm not wrong, max records per file, and then 1 million, make sure to be, I think you can do it both like integer or string. Let me take it a string. 1 million, or maybe you want to say like 500K per file. If it's more than 500K, go over the new one. All right, go over the new one. So because of time, I'm not going to run this one. All right, you can do it at your own and try it. For this one, let's see that. This one, repartition. So gender, guys, 3 partition. We ignored 10 partitions, and now we have 3 partitions, all right, because of this, right? And then you can download it, right? Double click, and if you want to download files, please go ahead. Or guys, also you can partition based on, you know, or you can do it based on 2 columns, this partitioning. So for instance, the data frame, let me copy exactly this one. All right, so guys, since we had 10 partition, we did it 3 partition. So once we decrease the partition, it's better to use coalesce. Even repartition works, right? Repartition works, but if we use coalesce, maybe because coalesce is for less number of partitions. So we had 10. Let's say here take like 6 partitions. All right. So right option header. So here I'm going to do it based on gender and category, both together, gender and category. Override. Let me see. Let me here say like, you know, I'm using, you know, let's say 2. Let's say partition, because gender and category. Let me run it and let's do wait for the result. So once it's going to be executed, we can discuss about, you know, operations and transformation. Guys, in data frame, firstly, we need to down partition. Okay, partitioning is done, right? Now we need to get familiar with data. Let's go through data and take some queries out of data and see really what's going on. The first operation or transformation we can take over, we call it select. All right, I want to go ahead with data frame 4, right? Data frame 4, because data frame 4 has this partitioning, 6 partition based on categories. It seems that it's going to be based on the number of categories, guys, because if we say that if there is like category A, let's say if there are, let's say 5 million, and if B is going to be like 5 million, it's going to be totally 10 millions, and then 3 partitions for A, 3 partitions for B, or maybe there are like 8 million, right? And there are 2 millions, and then it's going to be somehow might be 4 partition for A and 2 partition for B, right? This is what the Spark can decide about it. So still running, right? Still running. Let's do it. df4.select. So please select age column for me, salary column for me, and why not gender column for me. Dot show. Let me take 5. All right, take 5 records. Just, you know, getting familiar with data. So firstly, we need to wait for this to be done. and then go through this. To speed up, this stuff, okay, it's there now. So if I refresh, you can see that 2 partition come up. So if I go over this gender female, if I go to female, guys, we have A and B, because here, because of gender and category. All right, and then category A, 2, 4, 6. We have 6 partition because here we mentioned 6 partition. Please create 6 partition. And then like each of these partitions, these are belonging to female and category A. All right, we could partition and somehow filtering data. All right, so come over here. Let's say partitioning is done and then data frame select. So just, to get familiar with data, still age, null value. We need to deal with null value because on this tutorial, we are going to deal with volume, the size of data, and veracity, means dealing with missing values here. So let's say you want to filter data. All right, code. Let me use filtering. So how to use filtering? df4.filter. Let's say that I want to use 2 filter. The first filter and second filter. Then show 5 records for me. All right, so I want to say that df4.age column, I wish to be more than 30, and bf4.salary, please be more than, let me check. So it seems these are based on K, 17K, 35K. I want to be based on more than 50K, for instance. All right, you can run it. Getting familiar with data. Or might be you want to calculate, like the average of a specific column. All right, let me open the code. So let's say this df4, I want to group data based on category, right? Let's say category A and B, we have it, and calculate the average of salary for each category. So guys, you can see that this is the filter, that on this filter, the age, they are all more than 30. So you can see that is like not accurate because, guys, these are related to a veracity problem. These data are not accurate, right? You need to deal with this and remove this decimal part. Okay, we can say decimal, we can discuss shortly. So salary, and then the salary more than 50, right? These are more than 50. All right, we could collect it. So df4, as I said, that I want to group data based on the category and go through each category and calculate the average of salary. So df4, group by, based on category, please, for me. Then aggregate. What to aggregate? I want to aggregate the average of salary column. All right, so here, the mean, we need to import this, this function. So from PySpark.sql library functions. Okay, please import. What to import? This mean for me. And of course, the summation also I want to calculate. So mean, then you can say alias, means that give the new title. All right, let's name it the mean of salary. So what else? So this aggregation, you can see that this is open. All right, I can here close it. All right, and then send it next line. I want to make it more, interesting, like be readable. So mean of salary area. So guys, if you want to get rid of like this, why not here to say round? Okay, round it by 2. Guys, if you round like this, it's going to use like Python library round, but I have to import it here from SQL PySpark to say now this round is going to be executed in parallel mode. All right, so round to mean, come on, maybe next line I can copy the same thing and paste it here. I wish to say this is like the summation. All right, and then here the summation of salary at the end dot show 10 record for me. Let's see that, but we know that there is no 10 record because there are just 2 categories, A and B, right? If you put 10, we expect to have 2 records at the end, right? But let's take 10. Let's see what's going on. So while it's running, or maybe you want to sort data, like df4 dot sort, sort it based on weight column, based on salary. Guys, single quote or double quotes, right? Same stuff. Then ascending, please. Ascending would be false. And then show 10 again. All right, so sorting based on weight and salary into descending order. Let me run it. So what we can see here, you can see that the average is, sorry, the decimal is 2 point, because here we say round. So guys, this round here, maybe it's wrong because salary, as we see here, these are integer. These are not float. Even based on these output, we can, we can also verify that these are all integer, right? Not float. So since based on this outcome, we are making sure you can remove this round from, salary, just sum of salary. All right, you can rerun it. So make sure firstly complete the sort and then go through. Okay, you can see that sort is there based on weight. You can see that 99 at the top, and salary, and then based on salary. So here by chance these are 99. Maybe you would say that based on weight and score. All right, or maybe based on, let's say based on height and score. All right, so can you see that the average, and then the sum of salary is there. So it's gonna to calculate sorting for us. Or maybe let's say you want to rename a column. Guys, we all need to do all this stuff to prepare this data frame for the further analysis, either machine learning, optimization, statistic, or whatever you wish to do over data, right? Pre-processing is very important. Let's say renamed data frame. All right, rename data frame. Data frame, because I want to rename it. If you want to rename it, let's say df4. So let's come over here to still height even 99, and then score even much better, because here we have decimal, right? So we can see that these are based on descending order, right? From highest to lowest, right? It's coming up. So for renaming, I want to use df4. Then you need to use a method we call with column renamed. All right, what to do? I want to rename income column to double quote or single quote, same, to let's say annual income. All right, let's say annual income. If you want to do more, another one with maybe I can send it to the next line, and then also one more, right? One more. Press tab, one more. So here maybe score, you want to say like still same thing, annual score. So guys, I'm taking random titles, all right? And then these rename data, let's show 10 to rename it. Let's say you rename, but also you want to drop some column. What type of column? Let's see, reduce data frame is going to be df4.drop. What to drop? I wish to drop maybe this one ID column, and maybe you want to drop more. Let's say maybe even this height. I don't need that, right? Let's say height. I want to do so. And why not to show 10 and run it? All right. It seems these are, enough to be able to handle this pre-processing. You can see that annual score changed and annual income changed. All right, we could change them over. So here also we're going to drop them. One more thing still missing, this one is working with missing data. All right, these null values. Very important. How to visualize? First, we need to know how many missing values we have, right? And where they are. Let me close this one. Because we can see obviously age and annual score. There are null values, right? Null values, missing values, but the rest not visible. Maybe like gender or category or weight, they have also missing values. So ID is gone and height is gone, right? Because we dropped them. All right. So for missing value, first of all, we need to make sure how many we have. df4 dot, let's say select where they are and how many they are. Okay, I'm just zooming. df4 select. So I want to write a for loop. So I want to do it into a single line. So the single line means you need to do it between, bracket for, let me say C in df4 dot columns. It means that go over each column means firstly is going to be like age column, and then salary column, and then so and one by one. We have to say that since this is PySpark, we need to import again a few more libraries. Let's say from PySpark dot SQL dot functions, I need to import column. All right, why? Because if you say C here, if it's Python understands C is the column. But in PySpark, you need to say col C, means this is the column. All right. So I have to check. Please calculate the summation of this column that if they are is null. All right. If it's null, cast it to whatever is. If it's 0, if it's 10, whatever it is, let's change it to integer. All right, cast it to integer. Am I wrong here? So cast it to integer. And what else? Maybe you can say that alias also. All right, let's keep the same column name. Or if you wish, you can change it. All right. So then you need to get this one from here and paste it here. All right, that's it. Let's say missing values. All right. So here missing values. Since this is a data frame, let's say, or maybe just because it's a select. All right, dot show. Let's say show me 10 or just show. Let's see how many missing values there are and which columns having missing values, because here we want to deal with veracity. All right, perfect. So as we expect, only age and score. The rest of column, there is no missing value. So about 4 million record, about 4 million record, guys, is a lot, right? 4 million out of 11 or 12 million. Let me double check how many we had, like 10 million, right? So about 40% of data are missing. So 40% is a lot, right? We have to find a solution. Since here, I'm going to discuss different scenarios and different, solutions, let's say, for dealing with null values, I have to create a copy. In Python, it was easy. In Python, we should say df copy to create a copy of data. All right, and then say df copy. All right, but in Spark DataFrame, we have no this syntax. Dot copy is not working. So because of that, we have to say df select. All right, everything. This is the copy. All right, let's say that a logical copy that not affects data frame 4. All right, means df copy. So what I want to do, I want to say that df copy dot drop, guys, take it easy and say drop an A. All right, and then maybe here I wish to say to, or maybe I wish to say df clean. All right, so why not to visualize 30 record? The default is 20, let me say 30. So in this case, we are expecting to drop 4 million and drop 4 million. So might be they are not in the same record, and it's gonna be 8 million. 8 million data will be dropped, right? Will be dropped from this data is too much, right? So maybe maybe at this stage you can count it, right? DF column. I mean, you can check how many data there are now. All right, so all are gone. How to make sure they are gone? You can run this one again. All right, but make sure this is DF copy now. You can copy this one and take it over here after this and run it and make sure there is no. So, but what we can do also, why not to say df clean dot count? Okay, let's see how many records, because original one was 10 million record. Let's see that after dropping all null values, how many we have, how many records we have. So, or maybe you want to say that I'm not going to drop everything, right? I'm going to take over one column only. Let's say that in this case, I want to say that, or maybe let's name it here. Drop NA strategy. All right. For this one, I want to say that drop selected columns. So how many? So guys, can see that about 4 million. It means this is what I mentioned. About 6 million records gone, right? It's not really great because we missed many data. What we can do, we can take some other strategies like drop selected column. I want to say that columns, let's say to check, let's say something like this. Let's say we know that there are, maybe here you want to say age, maybe you want to say salary. We know that there is no missing value in salary, but let's say you want to take salary. That's it. Just these two columns, not the score one. Sorry, yeah, not the score one. Age and salary is 0, right? But let's run it to see the effect. So again, I'm going to do the same thing here. All right, and paste it here. Okay, so in the drop NA, I want to say that subset. Now I'm adding this attribute to say this column, please, for me. Only this column. All right, and maybe I'm not going to print it. Maybe it's better to, to do it like this, count them, that how many, and maybe this one I can cut it and come over here, and instead of show, maybe it's better to say, count after dropping. Or maybe in this case, you can see there are many missing values. Maybe another strategy is going to be fill missing values with a constant value. All right. So what we can do, still want to use exactly the same thing. Let's say this one. Okay, now guys, it's much better, 6 million. But it's still dropping, might be is not always the right choice. If you want to drop a column with many missing values, it's better to check. If it's not going to be a lot, maybe 1% of data, 2% of data, drop it. Otherwise, it's better to go through filling strategies like this. So df copy. All right. And df field, I want to name it df field. Df copy. I'll need you to fill null values, NA. How you need to define a dictionary? I want to say that instead of age, if it's missing, add 30. Another one was score, right? If I'm not wrong. Yeah, score. Let me double check. Yes, a score. So for a score, please add even 50, guys, random number. This is a constant, right? These are constant. So maybe in this case, we can say dot show maybe 40. Let's see more options here. If I run it, you can see the 40 record. You see this one. So, or might be you want to use these, fill missing values with stat. With a stat. With a stat mean with the average, with the median, with the mode, even this constant, right? This constant that we did here, constant. All right. So, but for this one, there are different options. I can introduce imputer technique. Imputer is a technique that is a part of machine learning library that provide a convenient way to perform imputation. All right, means dealing with missing values. So if you notice here, you can see that 30 is here, right, for missing values, 30 missing values, and 50 for, for a score for missing values. Maybe constant is not a right choice. You want to calculate the average. So what we can do, first of all, make sure to import PySpark machine learning library feature. All right, import this imputer. All right, so what we have to do, we have to call this imputer. Imputer, please input columns. This one, input columns. So we need to go over age and score. These are the columns, right, that we are having null values. Go to the next line. So, and then we can provide output columns. So output columns, please be not overwrite it. Do it on age, let's say imputed, maybe something like this, and score, right? Imputed. All right. So then you have to say a strategy. What strategy you wish to do? So for a strategy, maybe there are some discussion about the strategy. So you can see that median. So you can take them, take attribute out and then say set a strategy, set input column and so on. But it's better to keep it as attribute. So median, we can say here, here strategy, we want to use mean, right? The average. Also, this is default, right? If you remove it, if you remove this one, the default is, mean. So then let's name it, imputer. All right, and then maybe I can move them. Tab, press tab to be in, uh, next to each other, and then data frame imputed. All right, please, this imputer for me. All right, fit this in this imputer, fit it to data frame 4. All right, and transform it means prepare it and finalize it for me. All right, that's it. And then the show. Let me take 40 rows. All right, let's see the result. This is really great strategy that you can do this missing over these missing values. In very advanced configuration, you can say replace missing values or filling missing values with a custom logic. Means using UDF. UDF means user defined function, right? User defined functions. So how does it work? For user defined function, you need to write a Python code. So def custom filling. All right. I want to say that get the value for me. And then if value is none, means is missing. All right. So please return unknown. All right, else if it's not, return the value. All right, do nothing and return the value. All right, let's see the result. So age, and score are there, right? The null values. You can see that guy at the right hand side, we say the new column. So these are all, you can see the first one, 24.22 is this. All right. And but the null value, like this one, null, you can say that it's going to get average 49.99, 49.99, 49.99. If it's like still incomplete, it's still not valid because age cannot be with decimal, you can still work with veracity, right? How? Here you would say that for instance, I want to talk about a trick here. I want to say that df this imputed. All right, df imputed, please. All right, dot go with column, guys, because we have to work with the column. All right, not rename, just with column. Which column? Age imputed. What to do? We need to change the format, right? In this case, you can work with round that we discussed, here before, using round. I'm just going to take you to the round that we did. This one, right? We did round, right? You can take also this trick as well. So here, I would say that from PySpark .sql functions, import format number. Perfect. And here I wish to say that this formats number. All right. Then this column, if you haven't done this column, you have to add it here, right? Sorry. This column, this column, which column? This age imputed. 3 decimal, maybe, or maybe 0 decimal. Okay. So what does it mean? It means that go over this column and then do it without decimal point and rename it still the same name. Okay, let's keep it same name. And I wish to do one more thing. And here I want to say score. All right, and then score. Maybe for score, you can take, 3. All right. So let me say show, maybe 30. See the result. Let's see the result, and we can go through this version. So here for this advanced one, to be able to work with this, we need to import from PySpark .sql.functions. We need to import UDF, user defined function, and also UDF, and also from PySpark .sql.types. All right, we need to import, let's say, a string. I'm going to explain it, right, why we need that. So let's double check, this outcome. If we scroll over there, you can see that age, now these are integer without decimal, and for school 3 decimal. Perfect, right? We did the perfect job here. So here now we need to apply this user defined function on this strategy, replacing missing values. How to do so? You need to use this UDF that we imported. We have to say that these custom field, all right, that the output would be string type. That's it. And we need to name it custom, for instance, field UDF. All right. Then we have to say df with column. Go over, let's say I just want to do it over score. Okay, I wish to say that name it score field, the new title, this custom field UDF, Then what is the input, guys? Input is value. The value is data frame 4. The column is a score. So it means that custom field UDF, please take over this data, right? Take it over to custom field method, and the output is a string type. All right, this is the way we want to do so. Just this column. Let me, or maybe this df4, right? Because we are working with df4. Maybe I want to say that df field, df field.show, maybe 5 record for me. And there we go. So these are, guys, all the stuff you need to prepare your data, right? Partition data, tick. Pre-process your data, ticked, right? Means that you went through data, you understood data, you deal with missing values. In this case, you could handle, the veracity problems, and of course the volume problem by partitioning. And regarding these missing values, we are still able to work with machine learning algorithm. It means that you can use, like, many techniques like decision trees, random forest, gradient boosted trees, and many more techniques to deal with these missing values. All right, but I believe these are well enough. Or otherwise, you want to have sophisticated, solution for that. So if I go over this, you can see that score 79. You can see that still same. Whenever we have null value, change it to unknown, right? Because here we said change it to unknown. All right, perfect, guys. I hope you enjoyed the session. See you next tutorial.